start, you turn on the cold water, and it's hot. That's what I remember about Dallas. I used to fly out here and then drive to Waco County so I could buy the sort of fireworks that were illegal in California. And, you know, it's funny. My sister used to always say, Steve's going to wind up in prison or rich. But she left out or in a hospital. Well, things change a lot. San Jose changed quite a bit because of Detroit. Detroit lost 1 million people. San Jose, California is now the 10th largest city in America. Thank you. And it's really weird, but Silicon Valley is one county, and it's one of 10 counties in the United States where more than half of the people speak non-English. Whoa, and we're all working together. They came from all over the world to flow into the electronic success. Well, I grew up in Silicon Valley, but it was really like a valley with trees and orchards, the 50s and the 60s, you know. And what was your goal in life back then? Your goal in life, almost for everyone, is, oh, I'll grow up, I'll get a job just like me, a milkman or whatever, and I'll have a home and a family and send my kids to school, and I'll have money for entertainment and movies and stuff. And the dreams were much smaller. Now in Silicon Valley, oh my God, what company are you going to start, you know, and what are you going to, how much, you know, how many yachts are you going to have, and it's like that. When I was young, you know, and just, you know, you don't have any commitments to the world. You weren't pushed in a certain direction. I had very good parents in that respect. I discovered Tom Swift books about a young inventor who would go into the laboratory and he'd put together and build devices that would solve the problems of the world. Wow, this was my hero. Every few weeks a new Tom Swift book came out at the grocery store, and I'd buy them, and my electronic friends would buy them, and we loved it. So books often set your inspiration in life. Often, very time, you know, I run into so many people when they were very young in elementary school, they got a direction that is still their drive to this day in their career. I read a book called SOS at Midnight about some ham radio operators, and I thought, wow, these guys actually sent signals with Morse code, and they sent them to the next city, they sent them to the next state, the next country. Wow, this is Superman stuff. Back in those days, it was unheard of. Long since phone calls were very, very expensive. Well, at the end of the book, it said you can get a license by, you know, sending in for some information. And I said, oh my gosh, you can get a license when you're 10 years old. You don't have to be 16 years old. So I sent in, got the information, I took some classes, and I got a ham radio license. Now, ham radio back in those days was not like electronics today, where you buy something, you take it out of the box, and you start using it. It was, you take this big box of kits, wires, resistors, capacitors, turning knobs, big sheets of metal, and you start bolting it together. You solder things with a soldering iron in place, and you follow a set of instructions, and it takes weeks. Long, long process. It's one thing I had when I was young. Built a lot of projects where I was building them for weeks at a time, because that's good discipline. It's very good education for things you're going to do later on in life. And I built this ham radio, I built the receiver, and I built the transmitter, got them all hooked up and measured wires on the roof to the right size and got it working. And I could send signals to other people. How cool. I was like a Superman. And that's what electronics meant to me. You're doing something that nobody else in your school is doing, and nobody around you is doing. You're sort of very special, whether it's recognized by others or not. You know, and the funny thing is, people who build ham radios it's not necessarily academic to build things, but almost all the people who build things are the ones that turn into the inventors who can build things when they're older. For example, you can grow up very academic and be able to design things that you learned out of a book, but somebody else is going to do the wiring, and somebody else is going to do the testing, and somebody else is going to choose the type of parts and wires. You know, that kind of sometimes bogs you down on occasion. We grew up in Silicon Valley, and Lockheed moved in. Lockheed was probably the most responsible reason that we got chips when we did, and why it became called Silicon Valley. Local companies were making transistors, learned how to put several transistors on one little chip of silicon for the same price. So you got more out for the same price in. Jean Morey and others invented what's called the planar process, by which every single chip to this day, from about 1960 till now, before 1960 till now, every single chip has been made by this process. We've never come up with a better process. And it's a process of photographing over little structures to invent certain kinds of atoms into the silicon. So, and I got to see this firsthand. I went to an electronics show with my dad when I was like 8 years old. And a guy showed me, a man, might have been Gordon Moore of Intel, showed me a diagram that looked like a bunch of little buildings connected with roads. And he said, this is going to be our chip with 6 transistors on it. Oh my gosh, I told my dad, I said, we went home that night, and I said,
my 6-transistor radio, you know, which was my best friend in life. I could sleep with it, listening to music, and it was handheld with a little dialing device. I said, now we're going to have a better transistor radio, right? That's what the chips are going to give us. And he said, well, not really. The chips are so expensive, nobody can afford it. Only the military and the governments can afford it. That's how it is with the new technology. I thought, darn, we have to wait and we get the surplus, what's left over, is what we people get in our own homes. And I thought that people had appliances in their homes, things like washing machines, you know, dishwashers, and refrigerators, and these things. Oh my God, how did our grandparents ever live, our great-grandparents ever live without these devices? This was what the engineers should be creating, better life at home. So I was kind of disappointed to hear that the world of the military was more important than us at home. Well, I accidentally discovered in the hall closet a journal. You didn't find any information about computers anywhere in life back then. Not in bookstores, not in magazine stores. And I found this little journal that my dad got as a special engineer at Lockheed, and it described computers. It described zeros and ones systems. And it described forms of logic, like Boolean logic, where you can turn a statement with an and into a statement with an or. For example, I could say, if it's John and it's Tuesday, that's exactly equivalent to saying, if it's not John and not Tuesday, then don't turn the light on. So it's 2 ways to do it. And I started learning this thing. It was like a new type of mathematics that was easy for a 5th grader. I thought, my gosh, we don't need any higher level math. We don't need all this algebra, geometry, calculus, and so on to understand everything's in a computer. I'm going to tell you, to this day, every single thing that's in a computer that's digital, except for things like radios, every bit of that is absolutely not beyond any of the understanding of a 5th grader. It's just the way it is. I fell in love with this stuff from that journal. In my heart, I said, I'm going to love this little computer world, this computer game of drawing symbols that represent logic. Yes. What is a logic game? Logic game makes a decision, just like, is it John and is it Tuesday? Is the light switch up or is it down? It's just like a light switch. So I learned about this. That's going to be my most wonderful thing in life, learning how computers are made. You know, and I didn't know. I really didn't know for an awfully long time. And so eventually for science fair projects in elementary school, I did some incredible ones. I built a device with 100 transistors because my dad taught me how one transistor can be designed, how the electrons flow through the leads of a transistor and make it perform a function. Make a logic decision. It was logic. It's what you make computers out of. And I built a tic-tac-toe computer with hundreds of transistors. Every transistor made one decision about if there's an X here and an O there and an X here, here's where you should move. Those kind of decisions. And I did this in 6th grade. I was so young. And then eventually I built an adder-subtractor that could add and subtract these binary numbers. You can toggle switches, 0 and 1, 0 and 1. That's the language of computers. And you'd see lights come on or off, zeros and ones. And built this, and I look back and I think, oh my God, those projects were so much on the right path to learning to design computers, and I didn't even know it. I just did it because it was my fun thing in life and nobody else did it. I became pretty shy, and as a shy nerd growing up, you tend to want to work on things that other people aren't doing. You come home from school a lot of times and you're just, let me think about things that haven't been done yet, or a different way of doing something. And it was usually, you know, of course you have no money when you're young. In high school, my electronics teacher realized that I already knew all the electronics. You know, I've been a ham radio operator, and really, by the time I got out of high school, I was never going to have to worry about a job in my entire life. I was always going to be able to get an easy job as electronics technician at the least. Well, Mr. McCollum arranged for smart students to go beyond the boundaries of a school. A school limits your learning. And this might even be representative of what happens in companies sometimes. You see, our group and our manuals and our books, this is our learning. It's restricted. But if you can go out to, he let us, some of the students go out to industry, to go into companies, to see what the engineers were doing and work along with them. I got to go down once a week and program a computer. Computers were still, you know, way out there, you know, like beyond rocket science. And this was, oh my God, I'm Superman. And I wrote a program to run a knight's tour of chess, where a knight hits every square on the chessboard exactly once. Nothing came out. And they explained to me I have a bug in the program, a thing called a loop. And I started, the next week I was printing my printouts and, oh my gosh, my program is doing exactly the right thing. It will solve the problem. But I calculated it would take 10 to the 25th years. But what that taught me was that a computer that could do 1 million things a second, back when a human could do it the most 1 second, This million-thing-a-second computer wasn't able to calculate, solve simple problems. You need the intellect of a real human brain to figure out approaches to things that need solution. The power of the equipment alone doesn't do it. I discovered a little manual about computers that described a real computer that was being sold. It was the age of mini computers. They were coming from companies like Digital Equipment Computer in Boston, and from Data General, and from Variant Corporation, Palo Alto, and Hewlett Packard, Palo Alto. There were a lot of companies making these mini computers that were sort of the size of a big microwave oven. They had switches and lights, so you could toggle zeros and ones, and push buttons to get them into memory. That's what every computer looked like when you bought it, starting the computer. And what I did was I said, my gosh, I understood all this logic, making decisions. I had built a tic-tac-toe computer. I had built adders and subtractors. I said, I wonder if I could design on paper. I know I could never afford a chip, but I wonder if I could design on paper with chips that are made this computer. And I sat down, it took me weeks, and I wasn't very successful, and I got to it a few more weeks later, and I finally had most of it designed. And then I got manuals for more and more and more computers. How did I get these manuals in an age where you couldn't get manuals? Well, on Sundays, I would drive down to Stanford Linear Accelerator Center. Back then, it was the highlight of the world for physics research. Wherever smart people worked, they'd go lock doors. So I would drive in, I would always find at least one door unlocked on a Sunday to the main building, nobody in there, and I'd go to the library. In the library, I'd sit down on the floor, and I would scan magazines about computers that only special engineers got. And I could send in cards and order manuals for all the computers from all the manufacturers. When I got a manual of a computer, it described the computer. How many holding places does it have? How many instructions does it obey? What are their ones and zeros that equate to an instruction that says add? And I would sit down with my paper, and I would, using the latest chip manuals I started having my dad get for me, I would design the computers with parts, with chips. And then I did this almost every weekend. I just closed my door, and I would design computers all around. And I could never afford a single chip. Chips back then cost maybe $200 for the equivalent of a light switch. So you couldn't really buy a chip. But I loved doing this so much. And then I started, the thing is, I made a game. My game was, I've already designed this Varian 620i computer once with on paper. I wonder if I could design it better. What is better? And better to me became fewer parts. Fewer parts eventually became much simpler, much fewer connections. And I became very good at it. I developed tricks in my head for forcing myself to, I'm trying to beat my own little record. It's like I have a record. I designed this computer with 78 chips, and I'd go through again with a new chip that came out. I got it down to 73 chips. And then I'd work on it. I got it down to 72 chips. It was so important for me to save every little part. And I said, that's what engineering is about. Doing a job that uses less input and more output. Fewer things in, less and more out. So the company I'm with now, Fusion.io, when I saw their, let me describe these designs. One computer came out called the Data General Nova. You had to buy a computer with 4K of memory to be able to write programs like my little chess program. 4K Nova. Well, I sat down, I had a very different architecture of holding places of an instruction. It had like one long instruction broken into little pieces rather than 50 instructions to do different things like adding and subtracting. And I sat down and I designed it. When I designed it, I was shocked. It took half as many chips as all the other equivalent computers of the day. Half as many chips. And this was my goal in life. How did they do it? The architecture of the computer matched the building blocks, the chips that were available. It's like if you design a house well, building well, you design it around certain kinds of materials that you know are there. So you could use very few, very inexpensive, and get the job done, a better way.
Can you go
well,
take pictures of me?
I went to my dad and I said, I am going to own a 4K General Nova